All right, welcome. Thank you for watching this video. If you were absent, to get caught up, thank you. So we are learning today Introduction to Logarithms. By the end of class, every student is going to be able to identify what a log is and to know that the log is the inverse of an exponential function. We did an activator already. We are going to graph some exponential functions and their inverses and evaluate log functions by hand. There's a quiz on Thursday, and tonight's homework is 26. Now, you guys already know what an inverse is, right? We've done inverses a lot. So if we graphed a function, if we graphed a function, how did we find the inverse? We took the x and y and did what? We switched them, right? That's basically what an inverse is. The x and y values are switching. So we're going to do that today in practice and see that a log is just an exponential function that's inverse. Find the inverse of it. Okay, last night's homework, you can check your answers. So let's see if you got those. Okay, so first we are going to graph a exponential function, right? This is a growth or a decay. What's happening here with the y equals 3 to the x? It's a growth. It's 3. It's tripling every time, right? So let's go ahead and start like at -3, -2, -1, 0, 1, 2, 3, 4. All right, and then we plug these values in and see what we get. So I like to start in the middle, or these numbers are a little easier than the negatives, but anything to the 0 power, 3 to the 0 would be 1. Good. 3 to the 1. 3 squared, 3 to the third, 3 to the fourth. Okay, then I like to go backwards. So be careful. What is 3 to the -1 equal? 1/3. Good. That negative exponent makes a reciprocal, so that's 1/3. So this would be 1/9. And I can kind of use these values as a reference. So -3 to the 3 to the -3 would be 1/27. So notice how these values repeat. 3, 1/3, 9, 1/9, 27, 1/27. All right, we're okay so far? All right, so what do we know about an exponential function? Before I graph it, what should I put on the graph to help guide me? What's that thing called? Yeah. Yeah, that thing. It's a horizontal line. It's called an asymptote. All right, so it's at the line, it's on this line right here, the x-axis, but we call it y equals 0, right? Here y equals -4, 3, 2, 1, 0, 1, 2, 3. So this line is y equals 0. That will help me graph and make sure that I don't go below. We're not actually crossing the asymptote. So let's go ahead and plot these values. 0, 1, 1, 3, 2, 9. So when I go to -1, 1/3, I can kind of see where that is. -2, 1/9, that's really little. And then 1/27, I really can't see exactly where that is. I just know it's really small. Okay, so I'm going to graph in a different color. This is getting really close to the asymptote. Right? All right. Any questions so far? That would be graphing an exponential growth. So we know that inverses, we just take the x and y values and switch them, right? So now we're going to say, okay, well this is -3, -2, -1. And this would be 1/27, 1/9, 1/3, 1, 3, 9. Okay. So what happens if we plot these? This is a little trickier to plot because when I try to go to 1/27 on the x, it's a little tricky. Okay, 1/27 is the tiniest amount, and then down 3. And then 1/9, again, it's a very little amount. Oh, that is not a good plot. Let's try this again. 1/27 down 3. I think my pen is a little uncalibrated here. All right, 1/9 down 2. 1/3 down 1. Over 1, 0, 3, 1, 9, 2. All right. So it looks like we're growing this way, like that. Alright, who thinks they know where the asymptote is now? What's going on with the asymptote? Yeah. Sean's going up and down. He's like, yeah, now it's a vertical asymptote. Very good. If this was y equals 0, what is this one now? Yeah, x equals 0. Nice. Not to know. Alright. Cool. So I want to show you. I'm going to take a copy of this function that we just graphed. So I'm going to copy that and drag it over here so you can see how they relate. Aha. Does that look like an inverse? Did we do it correctly? What is that line right here that they... Yeah, the line y equals x is the line that it reflects over. Yep, it looks good. Okay. Let's move that out of the way. Okay. So let's go ahead and answer 3 questions. How are the graphs related? Well, awesome. They reflect over the line y equals x. Thank you guys for writing this with me. Determine the domain and range of these functions. Oh, no, just of the inverse. So let's talk about real quickly. Domain here was all real numbers. The range was only y's greater than 0. But now we have something different. Now we have domain and range of our inverse. The domain and range of our inverse is going to be over here. So here, domain isn't all real numbers anymore. It's only x's that are what? Domain would be what? X's greater than... Oh, wait. X values greater than what? Greater than what? 0. Yeah. All right. And the range are going to be what? Which y values are we using? All of them. Exactly. So all real numbers. And again, we could write that like in interval notation. From 0 to infinity would be our domain. And our range would be from negative infinity to positive infinity. And it can't actually equal. So that would be an interval notation. Are they both functions? How do we tell if something is a function? Good. Cheyenne, for every x value, for every x, there's only one y. So let's check, because I don't think we checked. There is only one y. So do we ever have repeating values here? If we do, for every x, there's only one y. We can also think vertical line test. Does it pass the vertical line test? Yep. This one, a lot of people say no. They feel like that is a straight line. They're like, oh no, it fails. But they're actually they're changing values. They're different numbers. They're just getting really close together. Okay, so yes, both of those are functions. Yes, they are both functions because for every x, there's only one y. Okay? All right, so there is now another function, the exact same process, but now we have 4 to the x. So I'm going to hit pause on the video. If you're at home trying this, please try it and then hit play so you can check your work. I'm going to let my students try it and then check their work. All right, so hit pause if you're watching this. Thanks. All right, we just got a great question from John. Thank you. The question was, do you get points taken off if you don't put arrows on the ends of your graph? And the answer is yes, because the graph keeps going. You have to show that it keeps going. All right, so this is what we should see, right? A growth, and it's quadrupling every time. And here, so here it's growing really, really fast. Here, it actually grows really, really, really slowly. Okay, in the beginning, there's a huge jump, but then once you hit 1, it starts to be a gradual, very slow growth. All right, identify domain and range. Who's got domain for me? Who's got domain? Yeah, what'd you get? Good, Sean. X is greater than 0, and the range, who's got range? All real numbers, everybody. Good, all real numbers. Wonderful. All right, is it a function? Is our inverse a function? Yeah, it is. It passes the vertical line test. Every x, there's only one y. Label the asymptotes. Oh, I already did that. So the asymptote on h, make sure you have y equals 0, and h inverse, x equals 0. All right. Here's where we start. Well, there's a little more review. Okay, we labeled. There's a little more review, and then we get into like what is a logarithm. All right, so using this function above, evaluate the following. So it says above, but they're on the other page. So I copied my tables from early this morning, and we're going to use those tables. All right, so here we have G, and here we have H. Now I didn't bring the inverse tables. I just brought the G and H. So when we're looking at this, we have to think about this critically. If I have h of 2, I have to figure out, well, what is that 2? Is that the x input or is that the y output? That is the x input. And if you ever are confused, I strongly encourage write h of x above it. And then you'll see, oh yeah, that x is 2. So we know x is 2. So if I input 2 into my h function, go to my h, where's 2? My output is 16. Now if I say, okay, what's h inverse of 16? That's saying, kind of like Jeopardy, what if the output is 16? What if the answer is 16? Because this inverse says we've switched x and y now, right? So if the answer is 16 here, then the input was 2. Yeah. All right, so I want you guys to try those. Find g. What is g of -1? See what you get. All right, so try the next 4 and then we'll check in. All right, so g of -1, good. I hear some explanations out there. G of -1 says, what if x is -1? Well, let's see. On the g function, if x is -1, then the output would be 1/3. But if I said, well, what's g inverse? Then I think, okay, well, the output was 1/27th. What was the input? -3. I have to switch them around. All right, g of 0. G of 0. G of 0. There's no inverse, so I do it normal. G of 0 is 1. And h inverse. Because here I have a 1 and I have a 1. So the answer is either 0 or 4. How many guys think the answer is 4? How many guys think the answer is 0? And one person raised their hand on each of those, and I have 30 people in the class. Okay, all right, let's try it again. Think about it. H inverse of 1. Is that Jeopardy and saying, here's the answer, what was the question? Or is that saying, here's your x, what's your y? All right, so decide real quick. What do you think it is? 0 or 4? All right, how many guys think it's 0? How many guys think it's 4? All right, we had lots of people say 0 and not many at all say 4. It is 0, because this is the Jeopardy version, right? Where I have the answer, the output there. So if the output was 1, what was the question? It was 0. Does that make sense? So our output and input got switched. All right. And that's actually what we're going to talk about next. So if I have this, I have, okay, given this function, describe the input and output in words. Well, the input are the exponent values, right? Are the x values that we're plugging into the exponents. The numbers we put in the exponent. And what are the output values? All of the output values are going to be powers of what? In this problem, they're going to be powers of 3. 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 1/2, 3 to the, not 1/2, 3 to the -1, 3 to the -2. But 3 to the power of what? So these are all going to be powers of 3. So the input was our exponent, the output was powers of 3. If I do the inverse, how is that going to change for my input and output? Yep, the input will be our powers of 3. And the output is going to be now what the input was And the output, our answers for the inverse problems will be, what was the exponent number? What was the exponent? All right. Now, logs are really fun. They're kind of like a puzzle. You get to figure out what number got me from here to here. And once you start figuring it out and what you're supposed to do, it's actually a lot of fun. Okay, so an inverse of an exponential function is called a logarithmic function. Okay, so the inverse of an exponential, g of x equals 3 to the x, we actually already graphed this in the beginning. What we graphed was log base 3 of x. Did you hear how I said that? Log base 3 of x. So we always want to read that, log base 3 of x. All right, how would we say this one? What would the inverse of h of x be? Anybody? Anybody? Yes, not to know. Log base 4 of x. Perfect. Great. Log base 4 of x. All right. Any questions so far? We're good? All right. Ooh, we are almost done. Okay. So please write what the log would be. So f of x is 2 to the x. What would the inverse be? Log base what? What's our base? 2. It's the same thing that our base was here, right? Log base 2. Notice I make the 2 little and low. I'm going to say it's called subtended or something. Like you have an exponent where it's up high. Superscript? Subscript? Maybe it's subscript. I don't know. But it's little and it's low. So log base 2 of x. Now, all of these are being plugged into our f inverse function. So I'd like everyone to write log base 2 of, log base 2 of, and log base 2 of. So here it's saying in the inverse function, right, in that function, plug in 8. Where are we plugging in 8? For x, yeah, for x, for in the parentheses. Good, Brent, good. All right, so f inverse, so we're plugging in the x, we're plugging 1/4. In the x, we're plugging 1. And then the exciting, fun part is we get to say, okay, what exponent, right? Our answer is going to be an exponent. What exponent got me from 2 to 8? 2 to what power gives me 8? That's what this is saying. 2 to what power gives me 8? 3, yeah. 3 is our answer. All right. 2 to what power gave me 1/4? Whoa, whoa. Let's step back a second. 2 to what power gave me 4? -2 is the answer. But 2 to what power gave me 4? Well, that's 2. But I don't want just 2. I want 4 reciprocated, right? So in order to reciprocate, I need a negative in my exponent, which is why you said -2. Good. What about 2 to what power gives me 1? 2 to what power gives me 1? 0. Good. Awesome. You got this. All right. So this concept right here is all we're going to practice tomorrow, is just evaluating logs. What power got me from here to here? What power got me from here to here? What about this one? What if I say log base 7 root 7? Woo! What exponent got me from 7 to the square root of 7? What is this? Can I change that to an exponent? What's the square root as an exponent? Log base 7 of 7 to the 1/2 power, right? A square root is the same as a 1/2 power. So 7 to what power gave me 7 to the 1/2? The 1/2. So 7 to the 1/2 power is that. So our answers are all exponents. Okay? So logarithms are great for figuring out exponents. Let me go ahead and pass out your homework. How much time do we have? All right. Thanks for watching. If you're at home and you were absent, you're awesome. Or for a review.